Good afternoon, sir.
Good afternoon, boys.
Afternoon, sir.
Good afternoon. I'm waiting for 3 minutes, then I'm starting. Only 2 of you are present now.
आ जाएगा सर, आ जाएगा सब.
आ जाएगा, हाँ. Okay, let us start. You are all lateral entry students. You are entering this college in third semester, in second year, in mechanical engineering so far, and civils will come in. What we have in this third semester, actually, you are starting your graduation from second year. What we have in this particular semester is, so we have a theoretical subject known as strength of materials, which deals with the strength encountered in different type of machine members or structures or other parts, which we use in different applications. But what are the strength involved in manufacturing these parts, and what is the capacity to carry this load? It is we are supposed to know before we design or manufacture the parts. Whatever its application, this machine parts, machines as a whole, or structural members are supposed to carry its working or carry its load, means how much force or how much tonnage of additional or external load is acting over these machine parts. We should know in order to design it perfectly, and in order to manufacture it perfectly, and in order to use it perfectly. So what we have to know first, by going through your subject strength of material, is there are certain standard machine members, machine parts, which has some technical names, like say prismatic bar, beams, structures like this. It has certain definitions, although they have very little practical difference between among themselves. But to make the problem comparatively easier, for your study comparatively easier, they are given certain definition, they are given certain classification, and this classification is based on the type of loading they are exerted up to. And now question is, what type of loading a particular machine member or a structural member is supposed to carry? Actually, this type of loading is extremely complex in nature, because they are variable in nature, they are variable time to time, that can vary within seconds even, and that can be a different type. That can be tensile, that can be compressive, that can be shear, that can be all of these things are working simultaneous, means at the same time all these different type of forces of different magnitude and different types are acting on the machine members. This makes the design of the machine members rather critical and rather difficult. And thus what we do, we simplify these loads considerably. What type of different loads we are applying, we simplify it by just separating them from one from another, and we go through the application of different types of loads separately. Sometimes we also go, there are multiple loads with different type of loads all acting separate, acting simultaneously. So we have to go through the application of those this load also. So what happens? We are simplifying the whole matter by simply resolving the problem. This particular machine will be subject to a single type of load first. Then we go through what will happen to it when it is subject to a multiple type of different type of loads. So first we have to know what are the different loads and acting on the part, and then you can ascertain or you can fix whether this part can carry this particular load or whether they cannot carry the load. Then you have to design accordingly, because if the part cannot carry the load, it will fail or break. So you cannot use it. So you cannot make that type of machine members like this. So you have to make a rigid and robust and strong machine member which is liable to take all these external loads. That is a part of the engineer's scope. Now, other than the practical, what you say, other than this theoretical studying of the different load system, you have to calculate, you have to measure the loads practically. Means what are the different type of loads a particular machine members they are subjected to. You have to check by yourself by using standard methods or standard machines for checking this. So you are always interested to know what are the different loads acting over a particular machine members, and you are not only you have to calculate it, you have to measure it, what is the actual load it is carrying, whether it is have the ability to carry or not. How will you do it? So there comes different type of test in which is carries in the preview of strength of material laboratories, which means we have tests of different types, say tensile test, compressive test, hardness test, torsion test, impact test, like this. These are the different test standards they are using for in the industry as well as in study or is in the scientific labs even for years. They have certain modification or betterment of their design, but basically they are all remain same for years. And these are the basic things we are supposed to check in terms of our lab as well as in your future practice in engineering applications. In my younger ages, we have used to do this test, but still in my older days, still this test exists and everywhere it is being used. So you can say this is a process which we are supposed to last long. Now, question is, what are the different type of tests we are supposed to do in a strength of material laboratories? There are different type of hardness testing. There are different types of tensile and compressive testing. There is different type of impact testing. There is a different type of torsion testing. So in the hardness test, what we are supposed to do? What is exactly you mean by hardness? What is hard material? You see, a material is supposed to be hard when it can carry certain type of scribe, certain type of indentation, certain type of marking over it. If we have the resistance ability to resist it, okay. This ability to resist the indentation or marking over a surface of a material is defined as this hardness. Harder the material, it will get more resistant to the scribing or this marking or this indentation over its surface. And softer the materials, it will give you less troubles. Say a rubber, a plastics, these are softer materials. You can scribe over it very easily. But say a cast iron rod, a cast iron bar, a steel bar, much harder material. You cannot scribe it by your own hand at all. You have to use certain elements, machine elements, certain forces are applied by machines to make it scribe or make it indent to know its hardness. So these are harder materials. Actually, in our practice, for your subject point of view, we are interested to know the hardness of the harder materials like steels, maybe mild steel, maybe hardened steel, maybe different type of alloy steels, maybe cast iron, maybe brass, maybe copper, maybe aluminum, like this. These materials with hardness, we are interested to know from the subject point of view. Because what is taught in your strength of materials, in your solid mechanics, as well as in subject is that only to understand the behavior of different type of steel and not different type of steel, especially mild steel and copper or aluminum or brass or bronze. These 4 or 5 materials are cast irons. These 4 or 5 materials are used for your subject point of view. We have to go through its strength. You have to go through its hardness in different types like this. But others are equally important. Just to reduce your workload a bit, we are given this type of job, this type of preview. We are using this type of hardness or this type of application of these 4 or 5 materials only, not the others. Now, What we'll do here in your lab, we'll go through the hardness of steel. Steels there are 1,000 different types of steels are available, but we are supposed to go through the hardness of mostly mild steels, other than copper, then aluminum, then brass, like this. So these are 4 or 5 items we are supposed to check in your lab set. Now, first of all, hardness is to resist the grinding or resist the indentation. Now, what we are supposed to do, what is the other words like tensile test? Tensile test is, we have a particular machine member. We are exerting a tension or pulling the rod, say a rod, a prismatic bar. A bar looks like a prism. We are pulling the rod by means of a force. We are pulling it to increase its length or draw it into air like this. And how much it can resist this load. This is the tensile strength of the particular material. I repeat, how much it can resist this load. So the strength is not the externally applied load, but the resistance in the application of against the application of the external load. That is strength. That is tensile stress, which is the external load divided by the cross-sectional area of the cross-sectional machine member to which it is subjected to. So, but it is how much load rod is creating by itself, by means of its strength, by means of your hardness to resist its failure against the external applied load. This is called the strength. It is defined as strength. When we'll go to the theory, you will go through the much details of this thing, much more application of it. It will be clear to you. The stress associates with another term, strain, due to the application of this external load. The size, say if it is pulling a particular machine member, this machine member is liable to be increased in length. It is deforming, it is increasing in length. And if there is a change in the length, this change in length is defined as strain. Means what is that? First, what I have told you, that is stress. Resistance to external loading. Next, strain, the elongation or deformation due to external load. It has more specific definition, deformation per unit length. Means a bar of 1 meter length is subject to a certain load. It deforms, say, a few microns of length. The strain is defined as a few micron divided by the original length. And this is defined as the load per unit area. This is stress and this is strain. And we are going through by tensile test. We check the tensile stress or compressive stress. What is compressive stress? Sometimes you are pulling the bar to increase its length, to increase its length, to increase its length, pulling the bar to increase its length. Sometimes it may happen. It will press the bar or compress the bar or try to reduce the length of the bar to a certain extent. That is called compression. Now, what happens here? Next comes, so we have to calculate, we are checking the hardness of the material, we are checking the tensile strength or tensile the compressive strength. There is another thing called impact. Impact means how will you load your machine member has different type. Sometimes you may load it starting from 0 to your maximum value. Sometimes you are applying your load all on a sudden. And thirdly, you are applying the load by striking your machine member with the load, which is called, third one is defined as impact load. Means you are applying the load by striking the machine member with the load or hitting the machine member with the load. This is defined as impact. It has different application is everywhere. And a bar, if you know the strength, the tensile and compressive is not sufficient. You have to know how well it can resist this impact and how tough the material is. So here by impact, we define the toughness of the material. But how you know the toughness? Toughness, what is the mean by toughness? The amount of energy you can refuse to absorb before it breaks. Amount of the energy, not the strength, load, and not maybe tensile, not compressive, not striving over it, but we are applying certain amount of energy all on a sudden. That is the impact. How much it can absorb before breaking. That is the impact strength or toughness of the material. Lastly, we are supposed to go the torsion. If a particular machine member, if we twist it, twist means what? Twist means applying a moment or a couple or a torque over a machine member, and how much you can resist, how much torque you can resist before breaking. That is defined as torsion or torsional strength. But this is the few properties we are supposed to check of the material. First, hardness, next, tensile strength, next, compressive strength, and impact toughness, fourth, torsion. For a particular machine member, we are supposed to check all this strength, and we have to ascertain this is well within our working limit. At least well within our safety limit, not more beyond that. Otherwise, it may break due to toughness, due to impact, it will break due to torsion, etc. Because exactly we don't know what is exactly applied, load is applied over the machine members. Either tensile only, either compressive only, or only shear, or only torque. I don't know. It may so happen they're applying all of them together, or a few of them together. Maybe with the maximum load, maybe somewhere in the middle of it. So we have to go through their strength in measuring all these four properties. Tensile and compressive stress, hardness, impact strength, torsional test. If you know all of them and it is well within your elastic limit, you can say your bars is set. Why you are doing like this? Why don't you calculate the forces or the type of forces, or we can define the type of force applied to it correctly? The answer is, it is extremely difficult. Almost impossible to know what type of loads are acting of the member, say for a 24 hours of its working, or a year of working, or a month of working. No, we don't know it. It is difficult to ascertain. But we have seen, if we go through the tension, compression strength, hardness, etc., everything within limit, this bar will operate. Without going to that very difficult theoretical practice, we are making it easier, more application oriented, and make it certain empirical solutions. That is called empirical solution or empirical equation. Not proved. It is not proved, but usable. This means these are empirical solution. Means what is meant? It is not proved. It is not 100% assumed, 100% perfect. But we have seen first of all, it is usable. Seen it usable. We are making this empirical solution, an empirical process of checking to make our job easier as well as job perfect and usable. So there is another limit, the elastic limit, which I should tell you at this moment. What is this? If we load a bar with certain set tensile load, it is not that it can carry all type of loads and it can carry any magnitude of load. But what will happen? It can carry up to a certain length, up to an amount of additional load. Afterwards, it will deform or distort or break permanently. But we will exert it up to that load, which is such that if you remove it, it will go back to the original shape and other properties. This load is defined as elastic limit. This is the maximum load a bar can carry, within which, before that, it will may deform permanently. It will not go back to the original shape, or it may break totally. So always we have to assume, we have to use the factor safety such that the load should be within elastic limit. These are the few instances. I'm just started with the strength of material. Don't get afraid, because it already sounds, although it sounds complicated, but it can use it time and again. And so that it will be very simple and easier for you to understand, and very simple and easier for you to apply in some other problems. Because the subject strength of materials, it's not a core subject. You have to design your machine members. That is the machine design of machine elements. You have to do with the acquired knowledge of this strength of materials, the acquired knowledge of solid mechanics. But these subjects are supporting subjects. And your basic subject, say for these cases, is machine design. You have to design the machines as per your strength, as per your other properties. That is your job. So you have to know these supporting subjects, also do the machine design of your concerned work. Now, what happens here? What I've told you, we are supposed to do the hardness test. Just 1 second. Just a second. Now, next, let us discuss what is the hardness. Again, First, I've told you the hardness is the ability to resist indentation. Hardness test is the ability to resist indentation. What do you mean by indentation? Say you are pushing certain hard materials over a surface and try to write something over it. If you can use it, no problem. But mostly in any case you will fail because you can't apply this indenter, so-called indenter over your surface because it is hard. It is not allowing to indent, allowing to scribe, allowing to mark over it. This property is defined as hardness. So we have to check the hardness, how much is the hardness of a particular material. So it is very clear. In order to do so, we have to indent the materials, means press the materials by means of certain additional method, certain additional items. What is this additional items? This is defined as indenter. By means of indenter, by means of applying the indenter, a certain load over the indenter, we'll resist the indenter, we'll make an impression or scribe or depth or depression over a surface. And we measure the surface and tally with those standards and say this much amount of hardness is there in this material. Now, in order to do so, just a second. छोटा की So I really understand what is going on here. This meeting will continue for another 10 minutes. Afterwards, I will again start the meeting and you join it again. Now, the hardness. The ability to resist indentation. Question is, how do you produce the indentation? How to produce indentation? We'll use an indenter, a substance, a parts, made mostly hardened steel ball, prismatic type, diamond, indenter. Prismatic type diamond indenter. How to force it? To force it in the work. By means of externally applied load. Now, 3 hardness testing processes are there. One is called Brinell hardness. Another is called Rockwell hardness. Thirdly is called Ficus hardness. Hello? Yeah? Good afternoon. Huh? No. HOD का paper. HOD. Ashish sir, give me a number, okay? A code. And please, we use that. Okay, use that. I also give you one, you can ignore that. Okay? Okay. Ficus hardness. Now, what is the difference between these two? The method of applying the indenters are different. Method of application are more or less same. Same amount of load applied is different. Different methods are used to measure measure the indent, and different standards are used to measure the indented hole, measure the hardness. So start with Brinell. For Brinell, hardness. What we have? Steel balls, hardened steel balls. Steel balls are used of 10 centimeter, 10 millimeter or 5 millimeter, 10 mm, 5 mm are used as indenter and nothing else. Load use 500 to 3000 kg of equivalent weight. And methods of checking, method of checking the indented hole, indent, a microscope defined as Brinell microscope. So what we have here, the Brinell's hardness test. First of all, what we use at indenter is 10 millimeter and 5 millimeter steel balls, hardened steel balls. What are the load used? We can load from 500 kg to 3000 kg of equivalent weight. We have separate loads varying from minimum 500 to maximum 3000 kg, which is not exactly equal to this type of loading, but it is can create by means of a vacuum system an equivalent weight of 500 to 3000 kg or to up to the indented point, up to the indenter, with which the indenter can be pushed inside your hardness test piece. Next is, what will be the first of all, you have to, this is the load, you have to apply the indenter, you have to apply the load, then you have to, what will be the first of all, next is, what is the test piece? Or sample or workpiece used in Brinell's hardness testing. Why you have to use separate test piece? Why don't you use the original machine member whose hardness we want to take? Simple answer is the test is destructive. In nature, what do you mean by destructive? It creates a permanent indent. It creates a permanent indent over the workpiece.